In data analysis, a very important concept is dimensional modeling. We briefly mentioned something about multidimensional analysis in the previous session, but let's take a close look. So when you look at the data, you can almost immediately see that there are two types of data when you look at any kind of a table. The first type is something that you can aggregate, you can calculate some data, some numerical value. For example, the units shipped, the amount of the dollar amount of sales. You go to a grocery store, you purchase a bunch of things. The first thing you will notice is the price and the quantity. You buy 3 canteens of milk, times this 3 by the price of the milk, you get the total of your for the milk product, and you add up milk, bread, everything, and you get the total. This total, usually this total is what we want to look at. Okay, so you look at the receipt and say, oh, I'm spending more money this week than previous week because this week I purchased some cherry instead of just buying apple last week, right? So this is some kind of analysis. You analyze this the total amount, and the reason you were able to do this analysis is because you are aggregating the sales dollar amount. And where do you get this sales dollar amount? You get that by multiplying price with the units sold and aggregate the different items. So these are typical examples of fact. What we call fact, they are calculable values. You can aggregate, you can do numerical operations, or sometimes you look at the stock price. Stock price going over the closing price of a stock in the past few days, past few months, and you analyze the pattern. These are calculable values, that numerical values that you can find trend. You can do some aggregation and do some slicing and dicing. This is the first type of analytical data. The second type of analytical data is what we call dimension. As I just said, when you buy things, when you go to grocery shop, you don't really just spend money on something you don't know, right? You purchase product, you purchase milk, you purchase the bread, you purchase spring water or Coke. These are the things that you purchase. And when you purchase and when you calculate like 3 canteens of milk times a price, you label this calculation as milk. Or you have 2 boxes of 2 packs of bread. This is bread, like whole wheat bread. This is the label, the product, the name of a product of this transaction. And also inside this, there are more things to the transaction that you will even notice. When you compare today's purchase against last week's purchase, you are doing a comparison between daytime, between your date, right? This is today versus a week ago. This is the comparison between different dates. And you were doing this comparison of aggregated fact along the line of a dimension, which is the date. Similarly, when you are not a consumer, when you are the manager of a retail store, maybe you want to analyze the sales between different cities. I want to compare the sales total of my stores in New York City against Boston, against the stores in Boston. So here, all the transactions, I'm looking for all the transactions with the label of New York or of Boston. You want to, first of all, filter the transactions, only get the sales for Boston. We're only with the labels of Boston and New York City. You are doing a filtering across the dimension, through a dimension. So for all this introduction, we can see that there are facts and there are dimensions. Facts are calculated along dimensions, like sales of a year, sales of a month, sales of a city. So when you do any kind of analysis, you always focus on fact. The end result must be fact, must be based on fact. But in order to make this fact, give this fact a context, you will need to provide with a dimension, and this usually comes through multiple dimensions. The analysis will makes more sense across different dimensions. Like inevitably, the number one thing you will consider is historical, right? You want to compare a week ago the cost a week ago versus what was the cost a week ago, a month ago. And if you are doing a managerial review, you want to check, what's the sales before I become the manager and after I become the manager. What was the monthly sales at that time, and what's the monthly sales now? How much I have improved the store sales. So this is the time dimension. Then you also do this across aggregations. Like you have 5 stores in New York City and 4 stores in Boston. You want to compare the sales of Boston and New York, then you need to aggregate. You will need to aggregate these things, right? You will need to aggregate, you will want to add up all the transactions of a city up to the city level. Then after the city level and filtered by a city. So then you probably even want to sort. What's my top sales city? What's my top sales store? Which day does my product sales best? For example, if it's a beer, maybe it sells best in Sunday when there are like football games. If you watch football game, the football TV, did you ever notice that they start to air pizza commercials in halftime? And they figure this pretty much when people start to get tired and get hungry and want to eat something, right? So pizza commercials come out in halftime, football halftime. And so if you are pizza store operations, pizza store manager or pizza store's executive, you want to check what's the sales of my best day, of my best sale day. Does this comes at Sundays? Or does this comes at Saturday or Monday? And if it comes on Sundays, is it always, do I always have a better sales on football Sundays versus April Sundays? So these are the things that you can see. And also you can sort, right? Or when you say what's the best sales, then apparently you will come up with some sorting. You will rank your sales aggregated to a certain level and maybe with some filter. So you can see that although the target of the analysis is fact, all this analysis must be done in the context of dimensions and of multiple dimensions. Through date, through geography, location, through a product label, and through customer, maybe customer address, these kind of things. So that's when you try to do analysis, that's when you want to perform certain calculations based on a set of schema. Calculations are centered on fact. So when we design the schema, we always try to put a fact or a table with a fact at the center of the universe. So for example, here we have the base fact table. We have a customer, product, and date. We want to put this fact in the middle so that you can have so that you can see it clearly that all dimensions developed across the fact. And this fact table will inevitably not only have fact, but also all the dimensions, all the dimension IDs. Then dimensions are placed around the fact. This is what we call lookup table or dimensional table or lookup tables. So the way they place this in this fashion, that fact table at the center and dimensional table or lookup tables scattered around, it looks like a star. When you have 5 dimensional tables, it definitely looks like a star. So this is what that's why we call it star schema. When you say star schema, star schema is always associated with dimensional modeling. Also, one thing to note is technically, when you have a dimension, you may have multiple attributes in the dimensional table, right? For example, in the time dimension, you may have a day, you may have a week, you may have months, the quarter, and the year. And if you want, you can, if you still remember what we taught in the normalization part, a year is probably not determined by fact. Instead, you can determine it's a functional dependent on quarter or months. So technically, you can create multiple smaller tables in along this line. A dimension of date, you can have a day table where you have a day and a week and a month. Then you can have a month table where you have a month and a year. Then you can have a year table, or may not be year, but basically you can split the table into smaller ones. This is possible. However, in reality, majority of the time when you do calculations, when you do data analysis, you prefer to use a SQL that is clear and simple. You want to have less table involved. So that's why when we do a star schema, usually we do a denormalized approach where we put all the attributes of a dimension into one table. Into one table, the advantage is then you only need to requires only one join. Because fact table usually is huge. If you can reduce the number of joins, this will be very helpful in performance. Of course, we talked about the downside of denormalization. When you don't have a second second normal form or third normal form compliance table, you have duplications, and it will be hard to do an update. However, comparing to the advantage of creating simpler SQL and have a faster join, in general, people tend to take the denormalization approach. So that's when you have a star schema, you will have only one level of a lookup table or dimensional table in which each table contains all the attributes of the certain dimension. That being said, there's nothing stopping you from breaking it down into third normal form compliant tables. So if you've done so, it will form something like this, like a snowflake, right? You can break each dimension, into a series of lookup tables. Each contains a certain level of attributes. This will form a snowflake. The advantage of snowflake schema is that if you also not only display fact on sort fact on a fundamental level, you also aggregate the fact. For example, if I have a monthly sales table, I not only store my sales on a day level as it happened, I also store sales on a monthly level. Each month has a record. Then it will make sense that I have a month lookup table. I will join the month lookup table with the fact table, with the month fact table, and join my day table with the day level table. This will provide us a much faster performance and more flexibility. Dimensional model is by far the most common approach of data analysis. And as a data scientist, you usually need to start with somewhere with the dimensional model. You get that data set, you need to look at what the fact is, what you can aggregate, what you can calculate. And then you may want to do some slicing and dicing, look at the different dimensions. So dimensional model is definitely going to be something that you're definitely going to run into in your future job.